There's a rule in calculus that if a theorem has its own name, it's really important. And so as we progress through the class, and especially in the spring, we will look at something like making a list of all the theorems that we've talked about that have their own name. We've had one already. We've had more than one, but the first one that pops into my mind is the intermediate value theorem. Not to be confused with the mean value theorem. That comes later.
What about the squeeze? Is that not as important?
Squeeze is also one. There you go. That's another one I forgot about. These two are very much related. I don't think this topic is that difficult, but again, it's a little skewed as to what I think is difficult and what you think is difficult. So hopefully you can understand and use Rolle's theorem. You can understand and use the mean value theorem. You can count to 10 in German. Yes? See? Go. You don't know. Ein, zwei, drei, vier, fünf, sechs, 7, 8, 9, 10. Liegt sehr gut, meinen Schatzis. Was ist los? So we got this guy named Rolle. He's a Frenchie. Michel? I guess that's a guy's name. I don't know. That's his name. It's not Michael. It's Michel. Michel Rolle. And he comes up with this theorem. So here's what I would like you to do. No, different roles. Is to read that theorem, process it, and explain it to me in English.
So is this French?
Yeah, thanks.
Where did the sea come
Yeah.
from?
I don't want to see.
Yeah, I take a crack at it.
Like the guy that did Fairmont's theorem just locked himself in his attic for 20 years.
For example, if like A is 1.
Well, that's a hasty generalization for all mathematicians, but it applies to a good chunk of
Which
them.
means that the derivative
All right, what do we
of that
got?
function,
Maybe you're waving your hands in the air like you just don't care. What do you got?
French guy.
I don't know.
Come on, look on the edge. What's the worst that can happen? You're wrong and we all point at you and laugh? Or beat you up and take your gold thing?
So if it's on the interval A to B, so then if you think of A as 1 and B as 2, if you plug in 1 into the function, it's equal to plugging in 2 into the function.
Okay.
So then the derivative of that function would be, I don't know what C has to
Yeah, that's what I'm
like,
Where's that sea power?
is that just,
But you just got a crucial part of the function. Okay, so remember in geometry again, we had a conditional statement. If an animal is a dog, then it barks. Okay. The if part is called the hypothesis, the then part is called the conclusion. So this theorem has a hypothesis. It says if blah 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 blah, comma then. So you've sufficiently explained the hypothesis of this theorem, except you forgot to mention these two big words. It's got to be continuous and differentiable for this to work. Okay. If it's continuous and differentiable, and f of A equals f of B, can you refresh our memory on what that meant? With a mouthful of goldfish?
wait, so what, F of A and F of B?
Doesn't that sound good? Some goldfish.
I also have a
Great.
Capri Sun.
You have a crappy son?
Yeah.
I don't really think I want to share a crappy son.
I love
If
that.
that didn't get decimated and the Cubs game wasn't on, we would have food, yes.
All right, go ahead.
Wait,
F of A equals f of B means what?
I forgot what I said. Oh, like the two, and like technically like the two endpoints.
Not
of the
technically,
inter-
they are the endpoints,
The
you're right,
endpoints
yeah.
of the interval, if you plug those both into the function, they'll equal each other.
Good, what were you gonna say?
I was gonna say like, so if f of a is equal to f of b, then like that means they have the same y value basically. So it's a horizontal line,
Bingo.
and then anything in between the horizontal line has a slope of 0. So that's why.
Not anything.
Or but in between the interval. Like, cause if. So
Okay, so let me ask the question that the people have already asked. Where'd the C come from? Oh, now we're getting somewhere.
Right?
Yeah. What's special about that tangent line in C?
It's a constant.
Which means
slope is 0.
slope is 0, it's horizontal, it's
It's a
horizontal,
con-
its
it's-
slope is 0.
It's
So wait, you haven't answered my question though, what's C?
a constant limit. It's a constant.
Props are just firing off calculus terms. You becoming like a, like calculus Tourette's? You just shot out calculus terms? Differential! Sorry.
No, it's a constant because the derivative of it is 0.
What do we know about C in relationship to A and B?
It's in between.
Good. Okay? We're there. Now, summarize that again. So what's happening at C?
Constant.
It's good.
Between A and B.
It's between A and B. It's a constant.
It's differentiable.
What about the tangent?
It's horizontal, there's no slope, slope is 0.
All of those mean the same thing. It's horizontal. It's equal to 0. Right.
Yeah.
Done. Good.
What is? So that's basically saying that.
Oh, no, we don't want to be using those big words yet. Roll didn't do that. He just fired off that simple concept, and then we use that later to do some max and min stuff. Okay. There's it. Yes.
I just had a question on the clarification of it. So it's a point in between an interval and whoa. And if you take the derivative of that point, it's gonna be 0. So that's like the consensus here.
So here's how you remember Roll's theorem. You've got ground.
Got ground.
We're on the ground. We picked 2 points on the ground. Let's see, what should I call that point?
Ground A.
How about A? A's a good call. Yeah, we'll call that A. And then we got another point over here on the ground.
B.
B is another good point. Okay. Level ground. That takes care of the hypothesis. We're starting and ending at the same level, on the ground. Then we have a hill. We'll start with a simple hill. Not to be confused with Miss Hill, the counselor. That's not her.
Or Rachel, the doctor.
So what Roll said is that if I take a big ball, are you ready for this? And I roll this ball up the hill, then at some point, I have to hit the top of the hill. Okay? Does that make sense?
Yeah.
It's almost kind of obvious, right? Somewhere between A and B, I've got to roll that ball up the hill until it hits the top of the hill, then it starts to roll down the hill. But what he's saying is, at some point in that interval, I got to hit the top of the hill.
Where does it say in the theorem that it starts and stops at the same y point though? Oh, if f of a comes off.
Because remember, f of a is the y value at A, f of b is the y value at b. And somewhere in there, so where is this point? What would we want to call that point?
The vertex.
How about C? C is a good choice, yeah. Somewhere in that interval between A and B, the derivative has to equal 0, which means you have to have a horizontal tangent line. Now, it doesn't have to be a hill. We could roll it down into a valley.
Double down C.
Start at A, end at B, at the same level. Roll the ball down. Then at some point it will hit the bottom part of that.
It could also have a horizontal tangent at the point before, right?
This says
At least once.
at least C. So if my hill looks something like this, bunch of C's.
Oh, I have an exception to the rule. I found one.
I don't want to hear it.
Corner points. Corner points.
It's not
And it's
continuous.
not
It's
differentiable.
He covered it all. He covered it all. He rocked me.
Good job.
Rolls.
Continuous and differentiable. All right, any problems with this? Okay, so Rolls comes up with this idea.
Is this like Rolle? He's French.
If you'd like to call him Rolle, you can. If you're on a first name basis, if you're close to him. No, he's pronounced Rolle. I believe it's Roll. Well, I've always
I have
known
no
it as
idea. I
Roll.
just feel like if you just add the little X like French.
That's one of the French
Roulette.
teams. That's here.
Who, are you taking French? Anybody taking French now?
They have the exchange thing.
Go get an exchange
Go
student.
get it. Go get it.
Okay, we good? Because if you get this, then the mean value theorem will be pretty easy. Any problems with this? Now, a couple things to notice is what we already talked about. You have to satisfy the hypothesis that, that it's got to be continuous and differentiable, and it has to start and stop at the same point. And I'll show you what that looks like when you're actually doing a problem. And then if that's true, then we go with all the other stuff. Lovely. Okay, we did that already. Good job.
The mean value.
So there's a function. We've got this nice pretty function. It's a parabola. It opens up. It's got some vertex somewhere.
Negative b minus.
We want to find where the C values are. And because it's a parabola, and because you guys are very smart, you realize that what we're going to end up solving for is the vertex of that parabola, because that's going to be that bottom of the valley for this Rolle's theorem.
Wait, for Rolle's theorems, you also take.
But who knows?
Do you take into account the critical points too, or no? No. Well,
Critical
because
points don't matter.
those won't be the vertex. So. Oh, it's right in between it. Perfect.
3 things. Sam, is it continuous?
Yeah.
How do you know? Outstanding. Is it differentiable?
Yeah.
How do you know? Does I've lost the ability to speak. Does continuity imply differentiability, or does differentiability imply continuity? How do we know that's differentiable? It's polynomial. Good. Does it start and stop at the same point? Or could we figure out if it starts and stops at the same point? Okay, yeah, we take a chance at it, right? How would I do that, Sam? Okay. All right, kids, what's f of 1 and what's f of 2? F of 1 is 0, and hopefully f of 2 is it? Or are you just saying that to make me happy? It is 0. Good. If those numbers don't match, you're done. Rolle's theorem doesn't apply because you no longer satisfy the hypothesis of the theorem. These work. Okay. Now what?
You gotta.
Find the derivative.
No.
Kev?
Find the derivative.
Attaboy.
The vertex.
Kev, what's f prime of x?
2x minus 3.
Well done.
Set it equals.
And Kev, what must happen next?
Set it equals 0.
I like that so far. And what's x, Kev?
1 or 2.
Oh no.
Oh, am I like solving that?
Yeah. You had me worried there. I thought you were struggling to solve this linear equation. I'm like, oh, we need to talk. 3 halves, beautiful.
How do you make it this?
Everything was going dreamily until senior year when he was found out. Question.
So if you get the same answer just finding the vertex,
Yeah.
will that apply to all like quadratic ones?
You know, I try to not use words like never, always, and all, and
Like coincidentally, does it sort
What's
of
the
mesh?
vertex?
well,
The vertex is
think about what's going on here. we've got two scenarios for a parabola. We've got that, or we've got that. Wow, that's supposed to be a parabola. So if we cut off a chunk of that using Rolle's theorem, so I take a horizontal line and I say, okay, there.
Mr. Darby.
I'm sorry, what?
The marginal revenue demands,
Average revenue.
Average revenue.
Profit.
Mr. Darby. Mrs.
I'm
Stanford's
confused.
close friend.
MC equals MI.
Professional, watch how I handle this.
so yeah, maximize profit.
So does that answer your question?
Yeah. So like,
What is the answer to your question? Based on these two pictures.
I would think yes, but like then again, I think only for quadratics that could happen, and then maybe don't trust it like. All
So maybe we should look at some different functions.
You know what? I think that's a great idea.
Wait, that's it?
I'm
Is that all we're doing? We're just finding it?
Oh no, we're not done yet.
Okay, yeah, that's why I was confused.
That's the point. Don't we?
Please. Oh yeah, okay, so f of 1 equals f of 2 equals 0, so we did that. Okay, hey Kev, got the derivative correct, good job. And then solve for x, so we got x being 3 halves. Which is also that c term where the function hits the top of the hill or the bottom of the valley, which we'll also then discuss, as John mentioned, those being maxes and mins. We got rolls under control here? Because we're gonna move on to this bad boy. That's it, we're done. We did what we needed to do. We found out where that c term is.
So x equals c.
Correct.
X
Yeah.
equals
Mean value.
C is the value of x where it hits, where the slope is equal to 0, which is a max or a min.
Why can't you just do a max or min problem like you're negative b over 2a?
You can, but this Rolle's theorem is what allows us to do those things.
So to make my life easy, I
Wait,
could
you said,
just put-
ask your question again. I think I may have misheard your question.
Why?
I had her for 3rd grade, by the way, misheard.
Oh.
Misheard.
Yeah,
So
3rd grade.
why do we just
She was hard to hear.
Hard to
Why
say.
does the Rolle's theorem make when we just do max and min? Like, should I make it-
They're the same thing.
So
So
I
Rolle's
can't-
theorem tells us that it allows us to look at a smaller interval of an entire function, and it'll guarantee that we're gonna find a max or a min in a certain interval, if you meet those conditions. Rolle's isn't the most practical theorem in the world. This is really the meat and potatoes. And Rolle's theorem allows us to get to this guy. Have you never heard that expression?
No, I said the mean.
The mean and potato. I'm using that.
Wait, can you say it again?
Wait,
I said that it's really the meat and potatoes of what we're gonna do, and she changed it to the mean and potatoes, because it's the mean value.
That was funny.
Oh, you're making dinner rolls?
Oh, dinner rolls with the meat and potatoes.
You were thinking
Totally using that one too. I like
we're
that.
all thinking about like Pillsbury dinner rolls.
What are we doing? Mean value theorem. Okay, so
Boy, it's really hungry.
let's explain what's going on here. We've got a continuous and differentiable function. So it satisfies the same conditions as Rolle's theorems. Rolle's theorem, he only had one. What's going on the left side of that equation?
Why?
That was shit for you. Everybody else, what's going on the left side of that equation? Not yet.
Vertex.
It's a derivative of the function at c. Okay, good. What's going on the right-hand side of that equation? That formula look familiar? You're overthinking it. Don't think like calculus students, think like algebra students.
Zero difference.
Oh wait, no, this is not.
Say again.
Slope.
Slope. It's a slope. y2 minus y1 over x2 minus x1. remember f of b is the y value at b, f of a is the y value at a. Now, it's fairly common that people write it as, you know, where it says or and then it's rewritten that way, but we're not going to use the or part. We're going to stay with the top one because it's a little bit easier to work with. The left side is the derivative, which is also representative of the slope of the tangent line to the function. What's that? The slope of what, Sam? I need more. What's it good?
At the point.
Who's talking, Mary?
At the point.
No?
Intervals.
Intervals. Right. Picture might help, yes?
I think
It's
it's a
the
good
slope
idea.
of what?
A picture might help, right? There we go. Okay. We'll get there. This is calculus, is it not? At this point, you should say yes. That's algebra. If we visualize the function we just had, we're starting at A and we're ending at B, and somewhere in between we've got a point C. This is saying that if I take the derivative, it has to equal the slope from calculus. So slope from calculus has to equal slope from algebra. Meaning the slope of the tangent line somewhere along the way has to equal the slope of that secant line. That's the line that connects the two endpoints. Okay? So let me put a picture up and it'll make a little bit more sense. This is the buzz term that you're going to use to remember MVT. Slope from calculus has to equal slope from algebra. So what mean value theorem does is it removes this restriction from Rolle's theorem about having to start and stop at the same level. You can start and stop anywhere you want. It just changes how the picture looks. And it looks like that. So I took a similar parabola, and instead of only looking at these 2 points where they start and stop at the same value, I've now said, okay, we're going to go from A to B. And if I go from A to B, then this point would be A f of A, and this point would be B f of B. And I can calculate the slope of that secant line. That's the algebra part of it. What the mean value theorem says is once you've calculated the slope of that secant line, somewhere along the way, the slope of the tangent line has to match it at least once. Okay, so you think of taking a tangent line and starting here, and as that tangent line rolls along the curve, eventually you're going to find a point where these two red lines are parallel. There might be more than one, but there's got to be at least one. Okay, so remember, Rolle's theorem, you have to check that you start and stop at the same point. Mean value theorem, you don't care if it starts and stops at the same point, you just have to do a slope calculation. Still, however, has to be continuous and differentiable. Because think, if I just remove a chunk of graph out of there, all this falls apart. And one of the most common mistakes is people start these problems without checking to see or explaining the fact that they are continuous and differentiable. Now every word I say, I'm trying to get a food/dinner fun into it.
But then, when it's not differentiable at that one point, then you just
Done.
You just stop the whole problem.
Done. Mean value theorem doesn't apply. Throw it out the window. Nichts sehr gut. Ja?
Yeah.
Ja.
Das ist
Das ist nicht gut.
yeah.
Ja.
Ich bin
Ja.
So are you looking for differentiability at the interval or at C?
Over the interval, it has to be differentiable and continuous.
So are like those points, so if there's like a piecewise within those points, it's like.
Right. So we're done with the theory, and I know it's still a little fuzzy, but if you see the problem in action, it'll make a little bit more sense. Okay, so let's take this. Got a nice easy parabola, and I got an interval from 2 to 7. Again, step number 1, is it continuous? Yeah, because it's a polynomial. Is it differentiable? Yeah, because it's a polynomial. We don't have to check f of 2 and f of 7. We just have to do a slope calculation. So, kind of, we do have to do f of 2 and f of 7. Yeah, we did that already. Yeah. Found f of 2, found f of 7. Also found the derivative, because eventually I'm going to set these puppies equal to each other. There's the slope from algebra. y2 minus y1 over x2 minus x1, which is also, graphically speaking, the slope of the secant line. Consider you asking a question, you just do it somebody to sleep. Did you have a question? Oh, okay. Okay, sorry. So now I've got a secant line that has a slope of 15. That means it's somewhere along this curve, this thing, the slope of the tangent line has to also equal 15. So what do you think I do with those two things? Set them equal. Solve. Yeah, look at that. 4.5. Easy peasy. See.
I was confused and I don't know what your preference is. Do you prefer to keep us in exact form or do you want us to go to decimals?
I don't really care.
Okay.
As long if you go to decimals and it's not a pretty answer, it's got to be rounded to 3 decimal places. Always, 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 always. Or it could be truncated to 3. I don't care. It's got to have 3 decimal places in
Yes,
it.
I know like on the test there was that quadratic that just wasn't pretty.
Yeah, 3 decimal places. Yeah. And that's why I gave you that problem on the calculator test, because then you had quadratic formula and then.
Imagine doing that by hand.
Oh, brutal. God, that's like slave labor. Who would ever ask a student to do that by hand?
Advanced algebra.
That's true. Okay, so let's take a more bizarre graph. 5 minus 4 over x. 5 minus 4 over x. Is it continuous? Yes? Why? Because it looks like it is. Who said it? Was that you? Because it looks like, that's not the whole graph, that's just a chunk. Yeah.
What's the difference between the brackets and the parentheses when you're talking about intervals?
Brackets include the endpoints, parentheses don't.
So I'm just gonna watch it in action.
Okay. This function is not continuous, nor is it differentiable.
So you stop.
What doesn't work in this function? 0. Okay, can't put 0 in for x. So therefore we now know it's not continuous, it's not differentiable. Does that mean we stop? No, because I've given you an interval from 1 to 4. 0 is outside that interval. So I'm just taking a chunk of the graph. I'm taking from here to here and looking at that. And if you look at the graph from there to there, you can see it is continuous, it is differentiable. So then we can proceed. Remember, the theorem says it's continuous and differentiable on the interval, not for all x's. Slope from calculus equals slope from algebra. Plug and chug. What's f of 4? 4. What's f of 1? 1. That's kind of strange, isn't it? Just a fluke. What's f prime? Ooh. Little practice there. F of x is equal to 5 minus 4 times 1 over x is how I would handle it. Or I would actually do, I lied, x to the negative first. So the derivative, f prime of x, not c. 5 disappears, bring the negative 1 down. I get 4 times x to the negative 2, which would be 4 over x squared. Woo-hoo. I think I have that in here. Hold on. Whoosh. Plus or minus 2. Happens in 2 spots. What's your problem? Oh, very nice. Did you hear what John said?
Yeah.
One of these isn't in the interval. What do we do with it? Toss it. So our answer then is just when x equals 2. So to put this together in your brain, you've got to come up with some way to do that. Whether it is just memorizing, which I'm not a big fan of, or understanding the slope from calculus equals the slope from algebra, and understanding what each of those bits means, or remembering the picture that we have. So that one we just did, we had a curve like this. You connect the endpoints and calculate the slope of that. That's our slope from algebra, which is 1. And then find that spot along there where the tangent line will be parallel to it. And that's what we've ended up doing. This line is parallel when x equals 2. You'll see problems, well, this one is the case, where you can get multiple answers, but then you have to ask yourself a simple question of whether or not that fits into the interval that we started with. Because remember, our function is not continuous everywhere, but it is on our interval. This is an actual bridge in, I think it's in Japan maybe, but they actually have the mean value theorem on a bridge.
Why?
Why not?
No,
I am
like,
so
no,
moving.
not like why in a judgmental way, but like why? Like why? Just whose idea was it? It's like one of those things where like they don't know like it's math, it's universal, right? Is that how the mean value theorem looks like in Japanese?
That's the, remember the or part that I had below?
Yeah.
That's the or part of that mean. That is the mean value theorem. Are we already out of time? Move. Where is it? We're on day 42. I'm out of time, and we get out of here at 42.
The inception.
Yesterday, I came up with another, kind of fun. You could say roll.
Dennis, come here.
Good one.
Perfectly.
Another reason why we should have had snacks today.
You're just hungry.
Where are we in the snack dilemma? I mean, have we just?
Just 2 weeks in a row.
Yeah.
Me and
No,
Olivia
that's
brains and